Okay, start recording. So from the past, we have completed the hypothesis testing for binomial lesser than, binomial greater than, binomial not equals to. Let's continue with Poisson distribution. Okay, so Poisson lesser than, Poisson greater than, and Poisson not equals to. So okay, just a recap. Okay, general procedure. You first of all you have to identify the correct distribution. Number two, you have to write the correct hypothesis. Number three, you have to identify the correct alpha and evidence, and write out the reject condition and make conclusion. Okay, do your calculation in with p-value method or critical value method. So let's continue. Okay, with Poisson distribution questions. Let's see. Let me get the questions. Okay. Let's see how do we actually do these questions. Okay, so this one is Poisson lesser than. Poisson less than. Okay, so we follow the step. Number one, okay, write the correct distribution, Poisson with lambda. Number two, hypothesis will be lambda equals to 8 and alternative lambda lesser than 8. Okay, and number three, your alpha equals to 0.05 and your m equals to 3. Then number four, okay, so we write out the reject condition first. Reject h no if p of x lesser than equals to 3 is lesser than 0.05. Okay, so evidence here and the alpha is over here. So that's your reject condition. Then we have a p-value method. Okay, so p of x lesser equals to 3. Okay, so based on normal writing, we'll have px equals to 0 plus px equals to 1 plus px equals to 2 plus px equals to 3. Okay, of course you can actually use your calculator as well to help you actually get the Poisson CD. Let's go to distribution modes. Poisson CD. Number 3, variable x is 3, your lambda is 8. So we have a 0.0424. Of course this is lesser than 0.05. Therefore, you are actually good to conclude that. Okay, reject H no. Okay, so what if I want to use the critical value method? Okay, what if I want to write critical value method? So that means we need to find its critical value. So p of x lesser equals to c that lesser than 0.05. Okay, so from calculator. Okay, from calculator, let's see what do we get. Select type, Poisson CD, list. Okay, so I use 0, 1, 2, 3, 4, 5, 8. So over here, I have a p of x lesser equals to 2, give me 0.0137. P of x lesser equals to 3, give me 0.0423. And P of x lesser equals to 4, give me 0.0996. So in order to identify the critical value, okay, you can see that the critical value is 3. Okay, critical value equals to 3. Okay, therefore we draw a number line. So this is 3. This is lesser than. Therefore this is the reject region. This is the do not reject region. Okay, and our evidence is 3. Okay, m equals to 3. So it's for under here. Therefore, we reject H0. Okay, because this is a reject H0 question, therefore the further question that we can actually ask is, okay, the actual significant equals to 0.0423 and the critical region, okay, critical region is x equals to 0, 1, 2, 3. Okay, I hope that you still remember how to actually do this. Okay, then let's see for more. Okay, question, let me try greater than. Okay, let's see greater than. Okay, one, correct the correct distributions, lambda. Two, write the correct hypothesis, lambda equals to 5.5. H1 is lambda greater than 5.5. Okay, step 3, your alpha equals to 0.05, your evidence equals to 8. Number 4, reject condition, so I write reject H0 if P of x greater equals to 8 lesser than 0.05. Okay, then I will have my p-value method. Okay, p-value method, so p of x greater equals to 8 is the same as 1 minus p of x lesser equals to 7. So I do my calculation. Binomial seeding, variable, I have 8 and this is 5.5 here. So this is not 8, this is 7 now. 7, 5.5. So I have a 1 minus 0 0.8095. Okay, so what do I get then? 1 minus 0.8095. So it will be 0.1905. Of course, this is not lesser than 0.05. Okay, so do not reject H0. So if I use critical value method, okay, so I need to use list first. Okay, so I use P, I want to find P of x greater equals to critical value C lesser than 0.05. Okay, this is my objective. So which is the same as I'm looking for 1 minus p of x lesser equals to c minus 1 lesser than 0.05, or p of x lesser equals to c minus 1 greater than 0.95. Okay, so this is what we're actually looking at. So I use my calculator. From calculator, okay, from calculator, Poisson CD3. Okay, I'll go for the least. Then maybe this one, this is 7. So I have 7, 8, 9, 10, 11. Okay, then this is 5.5. So I see that from calculator, p of x lesser equals to 9 is equals to 0.9462. P of x lesser equals to 10 give me 0.9747. So from here we can actually observe that, okay, this fulfill this. Okay, Therefore, I can conclude that C minus 1 equals to 9, C equals to 10. The critical value is 10. So I draw my number line. So I label 10. This is more than, therefore this is the reject region. This is the do not reject region. Do not reject. Okay. So my evidence, where is my evidence? My evidence is 8. 8 is over here. M equals to 8. So, of course, it's do not reject. Do not reject. H no. Okay. So over here, the critical region is x is greater equals to 10 because up to infinity. Okay, for Poisson. So over here, we do not talk about the actual significance because this one is a do not reject case. Okay, because this is a do not reject case. So we don't talk about this one. Okay. Then next, let's see what else do you need to know. Okay, before we continue with the normal distribution, okay, before we continue with the normal distribution, we need to look at the type 1 and type 2 error first. Okay, let's go for type 1 and type 2 error. Next section. Before we enter the normal, we need to look at the type 1 and type 2 error first. And type 2 errors. Okay. So over here, let's look at the table. Okay. First of all, let's say I have a H no is true. H no is false. Okay. Then when you do your hypothesis, is your H no do not reject. Do not reject H no. Do not reject H no. Okay, so this one is reject H no. Over here, we only use H no to avoid confusions. Okay, so some students maybe say, they use the word reject, accept, okay, true, false, H1 or H no. You may be confusing yourself. So the best way to actually remember it is just to remember it in one variable way. Okay, so this is, we only talk about H no, okay, the one that equal. And we do not I'm trying not to confuse you, therefore I use the word do not reject. I didn't use the word accept. Okay, so let's look at this table. Okay, so if H no is true, okay, you do not reject H no, this one no problem, this is good. Okay, this is good. If H no is false and you reject H no, this is also good. This one is also good. Okay, nothing wrong over here. Okay, so the problem is these two. Okay, if H no is true, you reject H no, and H no is false, you do not reject H no. What's going to happen? Okay, let's use an analogy. Today your dad has an informant that actually tell you that the well, okay, we shall continue. Okay, so what happened to this student? Let's say we use an analogy. Let's say your dad has an informant that saying the certain price for tomorrow will rise. Okay, so ask your dad to actually invest in that stock. Okay, so the information can be true or can be false. Okay, but it will be up to your dad whether to accept it or reject it. Okay, so if let's say the information is true, but your dad is not, do not believe it, and didn't do any uh, investment on it. Okay, technically your dad didn't include any money in it. So although that your dad didn't gain any money from it, but in the end, your dad also didn't lose any money. Okay. Compared to the second one, the information is actually false, but your dad actually invest money on it. So that actually caused your dad to actually losing money. So this is actually worse. The one that not so bad is called type 1 error. The one is worse is called type 2 error. Okay. So in any hypothesis testing, there will be two possibilities here that can actually occur. It can be occur the risk that you want to handle for type 1 error and the risk that you want to handle for type 2 error. Okay. When we calculate probability, okay, if we want to calculate the probability of type 1 error, the probability of type 1 error here is reject H no. H no is true. We will write like this. Okay, we reject H no is true. Then over here, the value that occur is your actual significance, which is whatever that we have discussed earlier, the actual significance. Okay, that will be the probability of type 1 error. For probability of type 2 error, it will be probability of do not reject H no, provided H no is false. Okay, under these circumstances, we need to have new information. We need new information. We need new information to do calculation. Do calculation. Okay, so let's see on how do we actually calculate this. Okay, let's go to example. Okay. Okay, let's look at this example. A test is being carried out on a binomial distribution with n equals to 15 for h no p equals to 0.3 with critical region 0 and 1. Okay, so let's look at the information. So 1, I have x is binomial distributed with 15 and p. 2, h no, p equals to 0.3. h1, okay, p is, don't know, they didn't state. Okay. Number 3, okay, so they didn't tell us the alpha, they didn't tell us the m. Okay, so number 4, the critical region is x equals to 0 and 1. Okay, so calculate the significant level of the test. So part 1 here, p of significant level. Okay, so we will do this is a alpha here. Alpha here, p of x, okay, equals to 0 and 1. Okay, they calculate the value for the critical region, the reject region. So I will have p of x lesser equals to 1. So if I use my calculator, distribution binomial CD, variable x is 1, n is 15, p is 0.3. So I have a 0.03527. Okay, so that's what I mean alpha. Number 2, because they didn't say any alpha previously, okay, so the probability of type 1 error, okay, is probability of reject H no, okay, given that H no is true. So this is from the definition. If you look carefully, the reject H no happens when 0 and 1. And H no is true is when P equals 0.3, which is exactly same as our calculation earlier, which is alpha. Okay, that will be 0.03527. Okay. Then if P is 0.1, okay, calculate the type 2 error. So for number 3, if I want to calculate type 2 error, okay, probability of do not reject H no, do not reject H no. Okay, H no is false. You can see that these are all definition. But when do you do not reject H no? You do not reject H no when x equals to 2, 3, 4, up to 15. If H no is false, what will be the p-value? The p-value, according to question, it says p equals to 0.1. So we need to calculate this. So this is the same as, okay, 1 minus p of x lesser equals to 1. So 1 minus, okay, select type, binomial seeding, variable, okay, x equals to 1, n equals to 15, but p now is 0.1. Okay, it's a new value. So I have a 0.549. That actually give me, okay, 1 minus 0.549. I have a 0.451 as your answer. That will be your type 2 error. Okay, so I'll let you learn about this first. Okay, nothing much we can do for practices now. What you need to do is to get used with the definition. When everything ended, then only you deal with the past questions. Okay, stop recording.